Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello students. So last class we have completed chapter 1, that is a data model, with the introduction of DBMS. Among them, the relational model is very important. Why? The relational model is a model which is trying to provide difference between DBMS and RDBMS. So this lecture, our main concentration is schema design. So in schema design, the topic 1 is dependencies. So entire schema design is been divided into 2 parts. One part is dependencies and other part is normalization. In dependencies, we would like to discuss few other subtopics, that is functional dependencies and attribute closures and minimal covers and decompositions and FDs implied by others and derivation of candidate keys and super keys. You can note down these topics before we discuss into each and every subtopic. Okay students, now we start with what exactly the meaning of the schema and why there is a need of a schema design and why the dependencies are ruling the DBMS and why the necessity of the normalization. So if you look at the concept of schema, so a schema is nothing but it is an object which is distinguishable by others, which is nothing but uniquely identified. Okay, so what is the concept of schema design? So when you say the concept of a schema design is, or you can say schema refinement, both are the same. So what is the schema refinement? It's nothing but overall design process of schema is the concept of schema design or schema refinement. And while doing the schema design, we are going to implement the concept of dependencies, and we are going to implement the concept of normalization rules. That's why this chapter is being separated into two parts. One part completely dependencies and other part is completely normalization. So now let us say, what is the meaning of a schema? I say, for example, employee is one schema. I say department is another schema. So schema is nothing but, in general example, I can say it's a structure, or I can say a table. Okay. So now what this topic is mainly dealt, now we are going to learn the topic called dependencies. In this, we are learning first of all functional dependencies. First copy them, then we will take what exactly the meaning of dependency definition. Then we will go through all the subtopics which I mentioned in the previous slide: attribute closure, derivation of the keys, decomposition, minimal covers, and functional dependency simplification. Okay, first copy so far. Okay students, I hope so you have got copied. Now schema design is a very important topic in GATE examination and any other public sector undertaking examinations. Why? It rules complete database management subject. So it is a very vast, schema design is very vast. In order to complete the schema design, it takes many number of sessions. So you have to watch carefully because it's a very important topic as far as GATE examination concerned. So now let us see what is the meaning of dependencies. Write a point. Dependencies. Every schema is associated with dependencies. These dependencies are categorized as functional dependencies, comma, transitive dependencies, comma, partial functional dependencies, and overlapping dependencies. Now let us go through, first of all, what exactly the meaning of functional dependency. Yeah, functional dependency is implied by an arrow like this. Example is alpha gives beta, or alpha implies beta, or beta depends on alpha, or alpha determines beta. These are all the different naming constraints. So what is an idea of functional dependency? Let us start with the functional dependency definition. Write the definition of functional dependency. Write them. It is a constraint between only two set of attributes. It is a constraint between only two set of attributes of relation schema. Next point. To prove the functional dependency between alpha and beta, the following condition must be satisfied. So, as I told you the definition, what is the definition? It is a constraint between only two set of attributes, that is alpha and beta of relation R. So, to prove alpha tends to beta, then it must satisfy the following condition. So what is the condition? The condition is as like this. That is, if tuple 1 dot alpha is equal to tuple 2 dot alpha, then tuple 1 dot beta is equal to tuple 2 dot beta. Very simple condition. So as far as this condition concerned, I can prove that there is a dependency, functional dependency between alpha and beta. And this condition must be satisfied for all rows. That's the meaning. So what is the meaning? Let us test with one example. So what is one example? I am saying there is a table R which consists of alpha and beta. And I want to prove alpha tends to beta is a functional dependency. What is the condition? If tuple 1 dot alpha is equal to tuple 2 dot alpha. So I am saying A1 and I am writing B1. So I am writing A2 and I am taking as a B2. So the idea is whenever you repeat the tuple 1, for example, I am repeating one tuple, then what has to repeat? The corresponding beta has to repeat. Right? You understood down. Now once again, if I repeat A1 once again, then what has to repeat? It corresponding tuple has to repeat once again to prove alpha tends to beta. If I repeat A2, what has to repeat? Can you guess? Yes, this is the answer. What is that? B2. So in this example, I can prove alpha tends to beta is existed in every row. So alpha tends to beta is satisfied, 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 alpha tends to beta is satisfied. So what is an idea? If you repeat any alpha value, you have to repeat its corresponding beta value is the concept of functional dependency. Okay? I hope you understood, guys. We will see a few other examples based on this. First get it, copy this. Okay, guys. I hope so you got copied. Now, we will look at into a few other examples so that you will have the confidence in order to prove the functional dependency in a good manner and quick manner. So for example, I am saying R with A and B, 10B1, 20B2 and 10B1 is asking prove A to B and B to A. Okay. So instead of definition, I will give you a flow chart so that you can understand better than the previous definition. So what is the flow chart in order to prove functional dependency? As like this. So in general, to prove alpha tends to beta, you have to check alpha is unique. When alpha is unique, by blind you can say what? Alpha gives beta. When alpha is not unique, then you need to be very careful. Two other conditions. What are the two other conditions? Alpha is not unique in the sense alpha is redundant. That's the meaning. So when alpha is redundant, then you need to check two conditions that then when beta also redundant. In this case, automatically alpha gives beta. When beta is not redundant, then I can prove finally alpha not gives beta. This is how the flow is happened in order to prove any kind of example, whether it is a simple or whether it is a complex. So what is this example is telling? So I say R has got AB and 10B1 and 20B2 and 10B1. He is asking you to prove A to B and asking you to prove B to A. Let us first prove A to B. So now you tell me in this the A is unique value or redundant value. In this the first tuple 10 is unique. So when it is unique, automatically what is proved? A to B is proved. And when you look at the next tuple of A, 20, is it redundant or unique? This is also unique. Then when it is a unique, automatically what is proved? A tends to B is proved. And what is the next tuple? A value 10. Is it redundant or non-redundant? It is redundant. So when it is redundant, you check this side. So alpha is redundant. When alpha is redundant, what has to redundant? Its beta is supposed to be duplicated. So when beta also redundant, then I can prove alpha tends to beta, otherwise alpha not implies beta. So as far as this concern, 10 is repeated, hence its B value is also supposed to be repeated. So luckily it is repeated here. So this side, this condition is satisfied and it is also proving what? A tends to B. It's clear. So finally we understand A tends to B is what? Proved. Now let us check B tends to A. So take same schema once again. So I am saying the data is given like this, and this time we would like to check B tends to A as far as this concern. and this is already proved. A to B is proved. So what is B tends to A? This time you need to look at, this is our alpha and this is your beta. Earlier this is your alpha and this is your beta. Now you tell me B1 is a unique value, so automatically what is proved? B2A is proved. And B2 is a unique value or redundant value? Unique value, so what is proved? B2A is proved. And this tuple is unique value or redundant value? Redundant value. So when it is redundant, when alpha is redundant, what has to redundant? Beta also supposed to redundant. So beta is redundant. So therefore, here also what happened? B2 is also proved. So finally we understand A to B is also proved, B to A is also proved. This is how you can easily prove functional dependency using this flowchart. Okay guys, I hope so you got understood. Now just copy that. We will do few examples of me and few examples of your class workbook. Okay, copy. Okay guys, I hope so you have completed this and you also better understood using this flowchart. Now let us see another example. I am saying R is given as Mn O and data is given like this. He is asking now listen carefully. How many are satisfied and how many are dissatisfied? We will see. As far as this concern, we will first identify M2N is proved or not. So in this, M is a determinant and N is dependent. Now you tell me, first our concentration is only M and N, not other attribute. Now you tell me, M is unique or not? Unique. M is unique or not? Unique. M is unique or not? Unique. That's it. So I can happily say M to N is what? Satisfied. And what is the next dependency? We would like to check N2O. What is N2O? This time N is a determinant and O is a dependent. Now you check N is unique or not? Yes. N value is unique or not? Yes. N value is unique or not? Yes. So which means N2O is also proved. Come back to Mn2O. Here Mn together is a determinant. Very important bit. Mn together is what? A determinant. And what is a O? Tell me. Dependent. So this time O depends on M and N combination. Right. So you need to check carefully the combination of data of M and N. Now you tell me, Mn is unique or not? Unique. Mn is unique or not? Unique. Mn is unique or not? Unique. So automatically it is also what? Satisfied. So whenever alpha or determinant is unique, then automatically beta value is automatically satisfied. So in this case, whatever three, all are being satisfied as the rules of functional dependency. Okay, get copy. Okay guys, I hope so. You have got copied. So we will look at another example. So for example, I am saying a table R which consists of A, B and C. So A1, B1, C1, A2, B2, C2, A1, B2, C3 is asking prove the following. Prove the above dependencies. So the solution. Can you do the first one? What is the first one? A tends to B. So in this, A is a what? Yeah, determinant. B is a what? Dependent. Now check determinant is unique or not. First value A1 is unique, satisfied. Second value A2 is unique, satisfied. Third value A1 is repeated. It's so dangerous. When A1 is repeated, what has to repeat? Its concern dependent has to repeat. What is its concern dependent? B1 has to do what? Repetition. But it is failed. How? AB, A1, B1, it's okay. A2, B2, it's okay. When A1 is coming, what has to repeat? B1. But what is given there? B2. And therefore, this is failure condition as far as A tends to be concerned. So A to B is okay, A to B is okay, but A to B is not okay. Therefore, I can write A not implies what? B. Let us check the second one, B to A. So what is B to A? Take B here and A here, B value, B1 C1, B2 C2, B2 C3. Now check it. B1 is a unique value C1, B2 is a unique value C2, B2. This is so dangerous. Whenever B2 is coming, what it has to come? C2 has to come. But here C2 is not derived and B also not implies what? A in this case. What is the third one? AB tends to C. So this time you take AB and C is a dependent for us, which is depending on AB together. So AB data is what? A1, B1, C1, A2, B2, C2 and A1, B2, C3. Now you can guess. So this time in AB tends to C, AB is a what? A determinant. C is a what? A dependent. So what do we understand? C depends on AB together. C depends on AB together. So AB implies C. That's the meaning. Now you decide A1, B1 is unique value. A2, B2 is unique value. A1, B2, it's not redundant. It's also unique. Why? There is no A1, B2 combination in the earlier. So this is also what? Satisfied. Finally, we will come to know AB tends to C is satisfied. And what is the next one? BC tends to A. So write BC data and A data. This time A depends upon BC. So what is the BC data? B1 C1, B2 C2, B2 C3. So what is A data? A1, A2, A1. Now can you guess whether BC tends to A is valid or invalid? Yes, obviously it's very simple. How? B1 C1 is a unique value, so it is accepted. B2 C2 is unique value, it is also accepted. B2 C3, it is also unique value because there is no combination of B2 C3 in the earlier, so it is also satisfied. And B2C is also what? BC2A is also proved. Finally, What are proved? AB tends to C is proved, and what is proved? BC tends to A is proved. So proved FDs, right? Copy this. Yeah, okay guys. I hope so. Now you understood how to prove functional dependencies. Easy manner, very simple. Alpha is unique or not, you need to see. If alpha is unique, then you say that automatically functional dependency is proved. If alpha is not unique, then you need to see whether beta is repeated or not. If beta is repeated against to that alpha value, then it is satisfied. If not, it is dissatisfied. Okay, so let us work out. So types of functional dependencies. There are two types of functional dependencies. One is non-trivial FDs and the other one is trivial FDs. Okay. So what is the meaning of trivial FD? Trivial FDs are by default satisfied by the relation. Okay. How do you prove whether it is a trivial FD or non-trivial FD? I will give you a shortcut. That is, if beta is a subset or equivalent to alpha, then alpha gives beta trivially. That's it. Simple definition. Next, what is the meaning of, in general, idea of trivial dependency as like this? Example for trivial FDs. How? Just look at the board. I say A tends to A, B tends to B, AB tends to A, AB tends to B, AB tends to C, ABC tends to D. Identify are the trivial or non-trivial FDs. It's very simple. What I said, if beta is subset or equivalent to alpha, then alpha tends to beta is trivial. I will tell you other shortcut also. What is the other shortcut? If RHS is part of LHS, then it is trivial. This is the shortcut. Now you tell me, RHS is what? A. It's a part of this, therefore it is a what? Trivial. And next one, B2B, RHS is a part of your LHS, therefore trivial. This is a part, therefore it is a trivial. It's a part, therefore it is a trivial. It's not a part. C is not part of AB, hence it is a non-trivial. D is not part of your ABC, hence it is a what? Non-trivial. So it's very simple. Trivial means RHS must be the part of what? LHS. Otherwise, it comes under into non-trivial. So we'll continue the next session with some other examples. There you can prove what is a non-trivial and what is trivial FDs. Thank you for watching the session. We'll meet in the next session.